Okay, so we're going to run some tests here today to determine how well some of these cozies and different things that we're doing, how much impact they make. So we're going to start off with testing these Heineken cans. And I have two of them. One that I have that just came with this cozy, and one that fits inside of this ziploc case. So we're going to, since one of them has this wick on it and one doesn't, I'm going to run the test 2 times, and we'll see if that wick, how much, if any, difference it makes. And so what we're going to do is we're going to test it both open and with the lid, and we're going to see how much difference that makes. Then we're going to test it with the cozy, with the bottom by itself, and with the top. So that'll give us 4 variations that we'll test out on that. Since I have the 2 cans, we'll have to do it twice anyway. I'll try to do it 4 times, but we'll at least do the 2 tests and see how those compare out. And since I do take this, since I do take the Ziploc bag by itself, we're gonna do some tests on it. Now, normally, let's put this back over here. Normally, I have this one that I made into the 2 parts that'll hold the Heineken can, but I don't really want to test that full out. So we're just going to test it with the short lids on it. And again, we'll test it by itself, with the lid, with just the base, and then with the base in the top. So that'll give us 4 tests on those as well. And since I have 2 of them, we'll run them 2 times to do that. The third thing I want to test is these. Now this is quite a bit heavier and everything else, but on winter, I like to take this because I can pretty much boil and bag cook with this. Once you dump the boiling water in there, you can cook rice, or you can actually cook things with this. So you can take, it doesn't have to necessarily be a boil and bag meal, so I like that. So I'm going to try it. When they come, let me see, one of these, they come with this little spoon on them. I don't normally take that. That's why they're all lost. But, so I'm going to try it by itself, just with this lid, just with the cup, and then with both of them. And I want to see if it really makes any difference in how much weight, if there's things that I can take off and make a difference. And then just because I'm interested, I think I'll probably test with my coffee mug too. Seems to do pretty good, so I'm going to test it out, and I may actually test that against a plastic one, so I may grab one of those. I'll be using this digital thermometer out here for testing, and we'll see how that works. Temperature right now is right at 26 degrees, and so beautiful day here in Montana. I'm doing this on my back porch so that we don't get a lot of effect from sunlight. I have a pot boiling that's reached critical temperatures, which here is about 203 degrees. I'm going to use this measuring cup. I'm going to get them all as close to 2 cups as reasonable. I may actually fill it to the top. I haven't really decided yet. We'll see whichever is easiest. Actually, I'm going to do it 2 cups because those hold exactly 2 cups. If I put more, that will be a problem. So anyway, let's get set up for our first test. Let's look at these. I'm going to set this one up to be a full shell. So let me make sure that this thermometer is going to line up. So this will be a full shell against an open top. And I'll do the same thing with the Heineken can, a full shell against an open top. And then with this, since I have 3 of them, we're going to test multiple ways. I'll do the open top. I'll do this one with just this lid on it. And then the last one, put those together so I keep everything from getting lost. And the last one I will do with just the cup.
I used a large pot just on my kitchen stove to heat up a large amount of water.
And then we'll come up with our next
boiling point is 203 degrees at my altitude. Now, when I first brought this out to the patio table, I set it on the table, and you can see that it started melting right away. Luckily, I moved that before it did break the glass on my table, so that was nice. So basically at this point it just became a matter of filling the pots, or setting up the different tests, filling the different containers, measuring the amounts, and measuring the amount of water that went into them, measuring the current temperatures that they started at, and then just repeating the process over and over again. So I captured all the results into this spreadsheet. Over here on the left side you see that I have all the different containers. That'd be the ziploc container, the heiny pot, the thermoses, and the coffee cup, and then I have each of the different conditions. Open is when I just had the pot sitting there with nothing on it, with just the lid that came with the pot, with the cozy that was along the bottom, and then the full is when I had the cozy and the lid and everything was buttoned up completely. From there I started recording the temperatures. So I had the starting temperature, and then every 10 minutes up to 30 minutes I recorded the temperature. These are all in Fahrenheit, and I only recorded the ones that I could do without opening the lid. So on the thermoses, I thought that'd be too much of a heat loss to actually try to open those up. And then I recorded the outside temperature and the time of day each time that I took those. When I had multiple tests, I averaged them out, and then this was sort of the average numbers that fit there. And so this would be the baseline from that. In the next column I just got a raw calculation of what was the total loss of temperature in degrees over that 30 minutes. So just subtracted the temperature that it was at the end of the 30 minutes from the starting temperature. Now I was surprised that the starting temperatures were as low as they were, given the fact that it was 203 degree water when I first walked outside, but it lost a lot of temperature by the time I carried it out there, filled the different containers, and then got my measurements. So around 20 degrees, so that really surprised me. So from that loss column, then down here at the bottom, what is the minimum degrees lost and what was the maximum degrees lost in my temperatures. And so I just captured those two values so I could use those later. Then the percent of max loss. So in this case, what I wanted to do was figure out for each container or each scenario that was set up for each container, what percentage of the max loss here on the bottom is represented by its loss in the loss column. So if you look at the plastic container with no lid, for example, it had the maximum loss of 86 degrees. So if you looked at its effectiveness, it was 0% effective maintaining any of those 86 degrees. So the formula basically became 1 minus the percentage of the loss that had. So it goes all the way down, and if you look at, for example, the thermos that had the lid and the cup on it, it was 93% effective maintaining those 86 degrees. So that's how I calculated that value. And then finally, just because somebody would throw it out there, now I'm sure if I had taken the water and thrown it on the ground at the end of 30 minutes, it would have been the same temperature as the ground itself. So if you took the outside temperature, which hovered right around 28 degrees throughout my tests, and you took the difference between the temperature of the water when it started and 28 degrees, if you looked at that as the maximum loss, then the plastic container with the open lid actually was 45% effective, keeping that temperature differential. Then you take it up, and the thermos with the full cap at the other end of the spectrum was about 96% effective, keeping that total differential. How realistic that is, I don't know, but it was another column I got to throw in my spreadsheet, so I did it. So what does this all tell us? When I look back and evaluate this information, I find a couple of interesting trends. I find that just the use of the lid, whether that be the thin aluminum lid or the plastic lid is actually more important to holding temperature than having that insulated cozy around the bottom. The ground isn't pulling as much heat as is going out through the lid. I found this a little bit interesting, and I'll show you a picture here at the end of what the table looked like, and you can see the big melted spots that showed up just from using this test, so that's a little bit interesting in itself. I did find that the difference between actual thermos and the cozies was a lot more than I had expected. I thought that the cozies would be in the same neighborhood as the thermos, and that really wasn't the case. They were in the same neighborhood as the thermos without the lid, and so that was interesting. So that tells me is that even though the thermos weighs a little bit more, I'm still going to take it on my winter hikes, because I like to take a more substantial pan anyway, so that it's bigger and I can use it to melt snow in a lot easier, and I can use it to it's big enough to carry the thermos in. Plus the fact that I hate to take and rely, when it comes to my only source of water, aluminum pot, and I'm only one drop or one misstep away from crushing it and being in real trouble. So I like to have the more substantial pot anyway. And then using that with a thermos, and it's going to be able to cook oatmeal or rice or any of those kind of meals by itself, and it also, even without the lid, it's going to hold those temperatures a lot better. So to me, that tells me that during the winter, taking a thermos is a very good idea. The cozy in the summer is probably plenty effective, so that would be great. So anyway, I had a lot of fun doing this, and let me thank you for joining me. Oh, let me show you that one last picture before I take off, and you can see here how interesting that is, that we ended up with all of those sort of moon landscape. So anyway, there you go, and have a good day.